Continuing on with our last page of factoring practice, where we're applying all the rules we've already learned. We're looking at this first example right here. Now this one, as an algebra student, little sirens should be going off in your head, because that's 4 terms. And there's only one way we know how to handle 4 terms. That's factoring by grouping. So you kind of group together the first 2 terms in your mind. And think they both have an x squared that you could take out. And then the back 2 terms both have a negative 9 that we could factor out. All right, so if I take an x squared out of the first 2 terms, that leaves me x plus 5. Then I take a minus 9 out of the back 2 terms, and that leaves me x plus 5. Oh, how convenient. Okay, so this is x plus 5, and then x squared minus 9. Now, when we first learned by factoring by grouping, we kind of stopped right there. But now we know that we have to keep going and going until we can't factor anymore. X plus 5 is unfactorable, so that's fine. Leave x plus 5. But x squared minus 9, that's totally factorable. That's a difference of squares, right? That's 2 terms, and they're both squares. So that's x minus 3, x plus 3. That's the easy factoring. Difference of squares is the easiest kind of factoring you can spot. There's a subtraction, and they're both perfect squares. And now we're done with that one. All right, so now let's move on to another cube one. Everybody loves those. So we have 64c cubed plus 1,000. All right, so 64 and 1,000, those are both even numbers, so right away you know 2 goes into them. But remember, you want the greatest common factor. And the greatest common factor of 64 and 1,000 is 8. So we'll take 8 out, and that leaves us, let's see, 8c cubed. Oops, c cubed. There we go, 8c cubed plus 125. Okay, so let's see. I need the 8c cubed. So 8c cubed is equal to my a cubed. And 125 is equal to my b cubed. So that means b is going to be 125 to the 1/3 power. Or if you like, that's the 3rd root of 125. And that would be equal to 5. So that's not too bad. And then the other one is 8c cubed, not x cubed, sorry. Those buttons are right near each other. 8c cubed to the 1/3, and that would be equal to the 3rd root of 8c cubed. Again, you don't have to show both of those, just pick one of them. It doesn't matter which one, whichever one you're more comfortable with, and it'll be 2c. Okay, so now I've got my a and I got my b. So I'm just going to fill into this lovely formula right here. Don't need to know it, just need to be able to use it. So my answer is going to be 8 in front. And then a plus b, that's 2c plus 5. Then a squared. Now this is where it gets tricky. I need to square 2c, all of it. So 2 squared is 4, and c squared is c squared. So 4c squared minus a times b, that's 2c times 5. 2 times 5 is 10, so that's 10c, plus b squared, which is 25. And remember, the good thing about the cube formula is that the back trinomial is always perfect, just like it is. It never can be factored, ever. So you can always just kind of ignore it. And we're done. Okay, so there's that one. Another practice with cube formulas, everybody's favorite. All right, now for letter C, we're in a bit more trouble, because letter C is the trinomial, and there's no greatest common factor, and our leading coefficient is 8. Boy, is that ever not pleasant. Okay, so we're going to have to multiply a times c, makes 8 times negative 10, that's negative 80. And the sum is 11. All right, so what numbers multiply to negative 80? Let's think. Negative 1, positive 80. That would make 79. Let's see, negative 2, positive 40. That would make 38. 3 doesn't go into 80. How about negative 4, 20? That would make 16. Negative 5, 5 goes in there 16 times. That's 11. There it is. Ding, ding, ding. Okay, so what we're going to do with that information is we're going to take our middle term, which was 11, and we're going to break it up into negative 5 and positive 16. All right, so it's going to be 8n squared. Let's see, minus 5n plus 16n minus 10. We're taking the middle term right here, and we're breaking it up into 2 pieces, right? Negative 5n plus 16n. That's our plan. Once we're there, then now it's factoring by grouping because now we have 4 terms. So we'll say this is equal to 8n, oh, excuse me, n comes out. That leaves you 8n minus 5. And the back two, 16 and 10, are both divisible by 2, right? So plus 2, that'll leave you 8n minus 5, which is good because we need the parentheses to be identical, and they are. So this is equal to 8n minus 5 and n plus 2. And we're done. All right, now we've dealt with a trinomial where the leading coefficient was not 1. Those are kind of brutal. Let's move on to the next one. Uh-oh, this doesn't look promising. It starts with a 4. But 4 is common to all of these terms, so we can take a 4 out. Oh, I think this is a typo. Yes, it is. I think I meant WZ there. Sorry, my fault. All right, so let's take a 4 out. That leaves us W squared minus 5WZ plus 9z squared. Well, that's much more respectable. Now our leading coefficient's 1 in front of that w squared, so that's much better. Okay, so all we need to do is figure out how to break this up evenly into 2 parentheses. I know it's going to be a w and a w. And what we need to do is we need to be able to multiply to 9, but add up to negative 5. Because 1 times 9 is 9. Here, let me make a table. So the product is 1 times 9, right, which is 9. But we need to add up to, what was it? Negative 5. B was negative 5. There we go. All right, so 1 and 9. So we could do negative 1 and negative 9. That would make negative 10, so that's not good. Negative 3 and negative 3. That would make negative 6, so that's not good. And that's it. There's no other factors of 9. So we're actually done at this point. Now, it's not prime because we factored out a 4, right? So we were able to do a GCF factoring, and that still counts. However, that trinomial inside that parentheses, that part is prime. So we're done. We can't go any further than that. Right? Nothing's going to work for us. All right, now the letter E. Again, starting with a terrible number, right? Let's see if we can factor something out of this. All right, looks like 7 goes into all 3 of those numbers. Looks like A, this term has an A to give, so let me take that out. And B, there's a B. All right, so let's see here. That gives us 2AB minus 3B plus 1. Right, because 3 times 7 is negative 21. Negative 3 times 7 is negative 21. 2 times 7 is 14. 7 times 1 is 7. And then AB is what we're taking out. So this loses all of its AB. This had an AB squared, so the A is gone. One of the B's is gone. That leaves you 3B, and so on. So now we need to be able to see if there's anything further we could do. If you tried to make it work out, if you try to go O equals 7AB and then double parentheses, the problem you'd run into is that it's not going to work, right? So if you try to put like 2A here and B here, I mean, and this just for fun, let's do like minus 1, because minus 1 is the only way you're going to get a positive one for the back, but a negative term for the middle. If you try this, it won't FOIL out correctly because you'll get 2AB for the first, you'll get 1 for the last, but outers plus inners is not going to work because outers is negative 2A and it's completely missing from this term. So it totally does not work at all, right? You can try it, but it isn't going to happen. So we were actually done right here. You took out a GCF. That's all that this particular problem had to give. The rest of it is totally wrong, right? Can't be done. In fact, I'm just going to even delete it, right? So we can't go any further than that. All right, now the last one. Let's see. Oh, okay. We've got another with the leading coefficient that is not 1, and moreover, I can't make it 1. I can't factor out a GCF. There is no GCF on this problem. So we are going to have to make a table. And it's going to be a pretty big one with that. Because we have A, which is 16, and C, which was positive 25. 16 times 25 is 400. So we're going to figure out factors of 400, but we need them to add up to negative 40. Okay. So to make this happen, realize you're going to have both of these be negative, because otherwise you're never going to get anywhere, right? So let's try it. So we could try -1 and -400. That would make -401. Okay, so positive 400 when you multiply them, but when you add them up, -401. -2 and -200. That would make -202. No good. -4 and -100. That would make -104. -5 and -80. It's -85. We're getting there. -6 and, oh man, how many times does 6 go into 400? Oh, it doesn't. Not in a whole number. It does it in a fraction. All right, we'll leave that one off. 7 doesn't go into 40. 8, -8 goes in 50 times. -50 times, excuse me. That would make -58. Let's see, -9. I don't think 9 goes into 400. Matter of fact, I'm sure it doesn't. All right, so then what about 10? 10 goes in. -10, -40. -10 times -40 would be 400. But when you add them up, you get -50. And then, all right, -11, -12, -13, -14, -15, -16. -16 goes in -25 times. That would add up to -41. And then -17 doesn't go in, -18 doesn't go in, -19 doesn't go in, -20 goes in -20 times. And that would get us, hey, -40. Of course, it's always the last one we end up looking at. Our life wouldn't be complete without it. All right, so we're going to break up that middle term, -40, into 16a squared. Instead of -40, we're going to write -20ab minus 20ab plus 25b squared. All right, so we took the middle term and we broke it up, right? That's the plan, right, to do this factoring trinomial thing. So this is -20ab minus 20ab. That's what we did. All right, so then let me break this up. This is going to be equal to, now look at the first two terms. They both have 4a. Okay, so you could take a 4a out. That would leave you 4a minus 5b. And now the back two, now you want to be careful because you want to have it match the one you already came up with. If you do plus 5b, that would give you -4a plus 5b, which isn't what we want. We want it so that the parentheses parts are identical. So they're both 4a and minus 5b. So to make that happen, because we're so close here, it's just the signs are switched. So what we'll do is we'll take out a -5a, and then that'll become 4a minus 5b. And then this is equal to 4a minus 5b times 4a minus 5b. Interesting. Or if you like, you could also write that 4a minus 5b squared. Same thing. Okay. And I'm going to be honest with you, I kind of knew that was coming anyway, but it's a little bit hard to spot. But when this was a perfect square and this one's a perfect square, that one can sometimes be figured out on your own just by thinking about it, because if you break it up evenly, 4 times 5 makes 20, and then another 20 would make 40 for the middle. But if you don't see it right away, that's fine. You can use this little table method and it will not lead you astray. You will be able to find the right answer. It might just take you a while to get there though. Like it took us a while to find the combo. All right, we are all done with all the review of factoring. So I hope this was helpful and enjoyable, and I will see you back here for more videos.